So those of you who are gone, they're getting their calculators out, and I just told them we're moving into polar, and before we can do the calculus of it, we need to understand polar graphing. So we're going to go all the way to the beginning. It'll take us, I think, about 2.5 days to get a handle on how to graph. Your calculator does graph these, though, and it's just going to be important for you to understand what your calculator is doing. But we're taking out a calculator, and we're going to hit our mode button. So go ahead and hit mode. You'll notice in Calc 2 you never left function mode, so you never had you never knew that there were 3 other layers built in there. So we did parametric last chapter. Now if you move over to polar mode, your variable, or independent variable, is now going to be an angle. That's why this is xt theta n. That's your independent variable. For functions, it's x that goes in. For parametric, it's t that goes in. For polar, it's theta that goes in. And when we get to series in February, it's n that goes in. But you'll notice when you hit y equals, when you're in polar mode, go ahead and hit that. What does it say? R1. So instead of x and y, we're going to have theta and r. Okay? And instead of y being a function of x, r is going to be a function of theta. So I'm just going to give you one and have you graph it. Do cosine 3 theta. R as a function of an angle. And then hit graph, and then either hit zoom fit or zoom square just to kind of be able to see it. All right, and you should be seeing what's called a polar parent function. What are you seeing? Yours is making it right now. What's it making? A flower.
Yeah.
How many petals?
3.
Okay. Now go back to the R equals and change it to 2 cosine 4 theta. I know what it's going to make, and you will too. By the end of the week, you're going to go, oh, that's going to make an 8-petal flower, and it's going to go out to 2. So we're going to have, and do a zoom fit or a zoom square, and I'll do a zoom square so it looks a little nicer, so the petals look nicer. And it's looking choppy because under your window you can also do a theta step and make it go slower. So now if you hit window instead of T step, you know what I mean? It says theta step, which will tell you how to move from one angle to the next. But when you do 2 cosine 4 theta, I knew you were going to see 8 petals because it has, just like when I say y equals 4x plus 2, you go, oh, it's got a slope of 4. It's going to go uphill. It's going to go through 0, 2. You're going to know that stuff about this flower. Does that make sense? So it's new. The calculus of polar is more difficult than the calculus of parametrics, unfortunately, because the visual is really hard. The pre-calc, not so much. So let's go in the notes, and we're just going to go all the way back and assume you know absolutely nothing about polar. I don't know what you guys know. Do you know anything about polar? Nothing? Perfect, because that's what I assumed. All right. So I'm assuming that we know not even what the coordinate system looks like for polar. So in our notes here, first of all, we're going to go all the way back. It's very similar to learning how to graph in any system. When you were in probably the 4th grade, they said, well, we're going to make a coordinate plane. It's actually called a Cartesian plane. And this is the x-axis, and this is a y-axis. And to plot a point, you need to know the x and the y, so you can go 2 to the right and maybe 3 up, and you can get directions of where to go on that system. For polar, we don't specify an x and a y. Okay? In rectangular coordinate system, that's a normal one, x, y. You specify an x and a y. In this one, you specify a distance, which is called r, and an angle, which is called theta. It's going to be awkward at first, and I'll tell you what you'll find me slipping up with one of the parts of it. But for polar, it's used mostly in like navigation and like in space. Things are laid out on concentric circles. So instead of saying let's go 20 miles east and 50 miles south, they say turn this many degrees and head out along that angle. Does that make sense? So you're on like a circular grid. So there's always what we call the pole. You can think of that as the origin. All right? And we have what's called a polar axis, which heads straight out. Okay, so you can kind of think of that. Think of it sort of as the x-axis, but it's not. And you will need to know how far to turn the ship and that'll be given to you, and how far out to go. And this R does stand for radius, but this is actually laid out on a concentric circle grid. So if this was 4 and this was, let's say, pi over 6, what it means is turn pi over 6 counterclockwise and walk out along 4 of the radii. So the thing that's awkward with it is this is the independent variable. Do you know what I mean by that? Like when you do x comma y, which one's independent? Which one are you putting in? That's x is the independent and it spits out the y. This one's backwards. Your theta, you need to turn first and then walk, not walk and then turn. So you're gonna be tempted to write. I even sometimes write it backwards. I'll go, okay, turn pi over 4, and I walked out 3, and I'll write pi over 4 comma 3. And what should I have written? 3 comma pi over 4. One way to remember it is a sneeze. Theta. All right. So the R comes first when you write them. So a little bit of just what the system looks like. So it is laid out with angles, and these are called directed rays, so they're always directed out from the pole towards that angle, and it matters. All right, so this is considered heading out from the pole at pi 6. This is considered heading out from the pole at pi 4. The blue circles are the R. So right here, if I wrote it as a point, I wouldn't write pi 4ths first. If the independent variable, the turn is in the second slot, and your R would be 1, 2, 3, 4 because it's 4 radial units out. So when you're plotting points in polar, you turn and you walk. Okay? It's a little bit more confusing in rectilinear than rectilinear because if I were to tell Lainey, I want you to plot the point 3 comma 5. She only has one option. She can only go to the right 3 and up 5, right? In polar, there's 4 sets of directions. So somebody telling somebody navigating a ship could tell them 4 ways to get to that point. And they might indeed choose that. If there's some obstacle here, they might say, you can't turn that way. So when I head out this one, let's suppose this is pi over 4 just to make our lives easier. All right? The most obvious way to write that point is to turn pi over 4 counterclockwise and to walk out how many units? 4. So when we write this as a ordered pair, we write R and we write theta, okay? But there's 3 other ways you can get to that same point. So it's already more complicated than a regular graphing system because I could actually have turned backwards, correct? How many degrees or radians, I guess, would I need to turn clockwise? 7 pi over 4. Still walking forward along what I call the radial, I guess is what I like to call it. But it's totally true that I could have done this. Okay, so I could have told the ship to turn all the way around the other direction and go forward. But there's 2 other ways to do it. I could tell the ship to turn this way, right? Wait. To turn in this direction and then go backwards 4. Think about that, right? So if I were to say to turn this far, which is negative, what, 3 pi over 4? If I did this, negative 3 pi over 4, and I put a positive 4 here, that means I turn to 3 pi over 4 and I walk along that one. That would put me here. But if I put a negative, it means walk the other way. I'm just going to let that sit. It's already more complicated, isn't it? So another way I could do that is I could say I could go back 3 pi 4ths radians, but I can't walk along that ray. What I mean by walking along it is you're always shooting out. I can't turn this way. Well, actually, it'd be right here, negative 3 pi 4ths. I can't walk that way. I have to go backwards. And what did I say to use to go backwards? A negative 4. You guys see if you can think out what the 4th set of directions is. How else could I get to point P by being given polar coordinates? There's another turn I could do. So again, I could turn pi force and walk straight along the pi force ray. I could turn backwards and walk straight along the ray. Do you know what the other one is? How else do you think I could turn? Anyone want to try it? What do you think? Nobody knows? Somebody has to, or is it because I'm recording? I could go this way, correct? All the way around to 5 pi force, but how would I have to walk? Backwards. Okay? So I would go exactly in the backwards direction. So I could go 5 pi fourths, and it's so tempting to write that first. But there's 4 ways I could get there. And then it says, how could we determine its rectangular coordinates? So today, we're not really doing any calculus. We're going to talk about, well, all right, let's head over here. We said this was the point 4 forward along the pi force ray, right? If I wanted to know its x, y coordinates, I would want to know how far to the left and how far up would I need to go. You can move between the two systems, just like when we did eliminating the parameters. Sorry, they came in to fix this today, and the lady who came in couldn't do it, so I'm still kind of stuck with my goofy pen. But there is a way you could figure that out. Let's see if you guys can kind of anticipate it. What do you think? If you know R and you know theta, what kind of math is going to help you get the x and the y? Trig. Wouldn't cosine pi force have to equal x over 4? Right? These shouldn't need to be memorized because it's not. Cosine pi over 4 would have to equal adjacent over hypotenuse. So what does x have to equal? What would x equal? Go ahead, tell me. 4 times, what's cosine pi over 4? 2 halves, right? X would be 2 times the square root of 2 over. I don't know what 2 root 2 is. Can you do that on your calculator? What's 2 root 2?
2 root 2.
Yeah. I want to know how far I'd have to walk to the right rectangularly.
2.82.
Does that look kind of good? 2.8? Kind of does, doesn't it? All right. So it looks good. So let's go to the next page, and we're just going to practice plotting some points for a second. Now, normally this is like a full unit in a pre-calc course, the parametric polar, just the pre-calc of it. We're doing it in a day and a half, so you just kind of got to be on the ball. But we're going to plot and label a few points. Point A, let's just do a nice walk along that ray going forward. Let's do a turn of, let's say, 5 pi sixths. And an R of 7. You go plot that. We'll check it in a second. We're just practicing elementary school plotting with collegiate coordinate system. I want you to put B at negative pi thirds. Let's go over here. Let's put B at negative pi thirds, and let's just do 5. A dead spot over there. Let's put C. Let's go negative 6 pi fifths, and let's go back 7, just so you can see the difference between A and C. And then for D, let's put that one at pi over 2, negative 4. If you can't plot them, your graphs are going to look really bad. Just like in, not elementary school, but for you guys in about pre-algebra, 6th grade. If you couldn't plot the points, your thing didn't make a line. Well, if you can't plot these points, your flower won't look like a flower. Does that make sense? So let's go see how you did. This means turn counterclockwise to 5 pi over 6. So you're right here heading that way, as long as it's positive, which it is. So you go in that direction and pretend there's arrows on these. You go with the flow and away from the pole in that direction unless there's a negative. Then you reverse it. So how many, did you guys count how many were there in here? 10? 1, 2, 3, 4, 5, 6, 7. It'd be right there. Do you have that one right? Okay. The next one for B, I'm to go against or with the clock. So I'm supposed to go to negative pi thirds, which would be this one, correct? So here's pi thirds heading this way. My negative pi thirds is this guy. I need to walk towards the arrow. So 5 this way. 1, 2, 3, 4, 5. Label that with a B. How'd we do on that one? Okay. The next one for letter C, I have you going negative 6 pi. Oh, I didn't want 6 pi fifths. I wanted 7 pi sixths. Sorry, I bet you were like, what's that? So we're going to stay on the nice cuts. So negative 7 pi 6, which means you're going to turn to this guy all the way. Negative 7 pi 6 is going to go this one, and then one more. So actually this guy. But it says a negative 7. So what does that mean I'm going to do? I'm going to go head along this one. 7. I think that's right about here. How'd we do plotting that guy? All right. And the next one is pi halves, which means just turn your ship, go this way. But I don't walk there. I actually go backwards 4. So my D is here. So that's just a little practice of plotting. It was quick, right? You're going to practice that in Delta Math today. So I just don't want to spend a ton of time on it. So next up is the relationships. This is more important, like how you move between the two systems. So make a chart like this. And then we're going to make, it's all about the right angle that gets made. So we're going to go make a little right angle here. It's now going to have an X that you're used to, a Y that you're used to, an R that's the hypotenuse, and a theta that's the turn. XY, again, is rectangular. Our theta is polar. We're going to move between the two. You can graph lines in polar. You just have to know how. All right? So sometimes the polar system's way better. Watch this. Go to your graphing calculator just for a second. In rectangular coordinates, graphing a circle is impossible unless you do two functions, right? A positive half and a negative half because it's a function graph when you're in function mode. But if you just hit R equals 4, what do you think it's going to graph? A circle with a radius of 4. And you might say, well, what's theta? Theta's anything. So that's why it makes the whole circle. It's kind of like y equals 2. And you do a horizontal line and you say, well, what's x? It's anything. You know what I mean? So when it's just r equals a number, now hit zoom square, and it won't look like an oval. Do you see why? Like if you were in function mode, working with circular things in some high levels of science, that's very taxing. But if you want to be in a high level of science and be in polar mode and graph a circle with a radius of 3, what's the quickest way to do it? R equals 3. Done. Okay, so to move between the two functions, we're going to go like this. The relationship between the sides is x squared plus y squared is equal to r squared. So if I know x and y, I can easily get the r. It's just the Pythagorean theorem. So I'm going to say r is equal to the square root of x squared plus y squared. So the r is really easy to get. If it's in, if we're in rectangular and I say graph the point 3, 5, and I say, well, what's the r going to be? If we're in polar, you're going to go 9 plus 20 by 30, we're at 34. It's the hypotenuse, mate. Does that make sense? So that's a really easy move. So we're going to go up on the top here and write rectangular to polar. I can't understand what that means. Rectangular is xy, where y is a function of x. Polar is r theta, where r is a function of theta. Kind of weird. Okay, so let's go down and talk about how we'd get the theta. Anyone want to tell me how I'd get the theta if I know the x and the y? Yeah, inverse tan, exactly. So tan inverse of y over x. So if you know your x and your y, you can get r and theta. That's not really calculus. Do you see why this is a pre-calculus of it? It uses some trig. going the other way, if you know polar, how could we get back to the rectangular? Well, we're going to draw that same picture. And on this picture, we're going to say now we know the r and the theta. And I'm going to use two different colors. So those are the things you're given, and you want the x and the y. And somebody said it last when I was doing it on the other ones. We know that the cosine of the angle is equal to its adjacent over its hypotenuse. So if I want to know what x is in terms of r and theta, I get x equals r cosine theta. Now here's where sometimes kids go, oh, maybe not at your level, but the AB would at this. I just heard some of them talking about it in our last chapter. They're like, I kind of never got why cosine's x. Did you guys get why? I mean, probably not. Like, because your teacher told you, right? Am I right? They told you cosine's x, sine is what? And you're like, okay. Right? But here's why. Because on the unit circle, what's r? And if it's the unit circle, r is 1. Yeah, so it's just x is cosine theta. Okay? Y, the sine of theta is going to be opposite over hypotenuse, and y is r sine theta. But if it's the unit circle, that's what unit means, is 1, then it's just cosine theta sine theta is x comma y. Does that make sense? It's kind of cool. Most kids are, and it's hard to explain when you're not at this level that it's actually a polar reason. All right, so now we're going to go over here, and this is what I just told you, and we're just going to do a little practice with some points first, and then we'll do some equations, and then we're going to call it quits for now. We're not going to graph really anything today. This says find the rectangular. So right now, I'm on this circular concentric circles, and I'm being told to go down negative pi over 6 and forward 3. So let's see where that is. So the negative pi 6 means go this way, so it'd actually be this turn. And because that's a positive 3, I want to walk 3 out along that directed ray. So it'd be 1, 2, 3. It's going to be right about there where I can't make a dot. Let me try. See if my black will go right there. All right. But if my goal is to figure out, well, how could I walk there if I put this on streets north, south, east, west? Instead of turning and walking, you're going to tell me how far right to go and how far down to go. So you're just going to make that transition. Well, how do you do that? Well, we know that our x is equal to r cosine theta. You're going to be using that a lot, by the way, in the calculus, that x is r cosine and y is r sine. Anyway, so we're going to do 3 cosine negative pi 6. So you do need to know your unit circle. You don't need to know the 12ths. We're going to just go by pi 6 around there. What is cosine of negative pi over 6? The same as pi over 6. And what is it? Because it's the same x value. What is it there? You have 2 options.
Root 3 over 2.
Root 3 over 2 is the correct one. Yeah, so this would be 3 times root 3 over 2. If I asked Keaton to do that on the calculator, that's how far we go to the right before we started walking down. Okay? For the y, it's going to be r sine of theta. And sine of pi 6 is a half, but over here we're down, so that's going to be negative a half, so negative 1.5. So what it means is this point that's 1, 2, 3 out is actually 1, 2, 3. I can't draw it very well. Is this far to the right and 1.5 down. What do you think? Now go in reverse. What would be the polar coordinates of the rectangular point? That's, we're going to have to be a little careful, so tune in if you tuned out. I know it's been kind of easy, but polar means you need the r and you need the theta. And I know negative 2, 6 would be negative 2, and then I'm going to go like this. This is why they call it rectangular, because 2, 3, 4, 5, 6. I kind of head over. It's somewhere up in here is negative 2, 6. Ah. I'm gonna go like this. No, I'm not. I'm trying to graph. I'm so frustrated with my smartboard. I want to kill it. And I asked them to fix it today. There's a sub in, and she had no clue how to fix it. Anyway, all right. So the R is always easy to find. What's your R going to be?
2 square root 10.
Yeah, root 40, or if you cleaned it up, 2 square root 2. What that means is if I went 2 to the left and 6 up, the hypotenuse is going to be 2 times the square root of 10. That's my R. So if I gave directions, I'm just going to go root 40, comma. Here's where you have to be very careful. Watch. So you do have to remember some pre-calc in order to do this, and I don't know. We'll see if you guys remember. So we know we go tan inverse of 6 over negative 2. So go do tan inverse negative 3 on your calculator. And I have to tell you how your calculator's programmed, because there's always 2 places where sine is a half and 2 places where cosine is pi over 4 and 2 places where the tangent's negative 3. So we've got to be a little bit careful with that. So go do arctan 6 over negative 2 and tell me what you get. Negative what?
1.249.
Okay, we'll go 3 decimal places. 1.249. Your calculator's programmed that when you do tangents, arctangent, it's going to spit you out between negative pi over 2 and pi over 2. Because it's based on the graph of tangent, and it's a primary graph being between negative pi over 2 and pi over 2. So it fits you there. So what your calculator is telling you is that one way I can get a tangent of negative 3 is if I go down 1.249 radians. So let's pretend that's like right here. Negative 1.249. Well, I know negative 26 isn't over here, correct? It's this way. So you have to figure out what to do to get that way. So instead of, I'm going to go like this, instead of going down 1.249, you have to figure out, well, what would be that term right here? What you're going to have to do?
Pi minus it.
Pi minus it. Yeah, what made you think of that?
Because a full circle is 2 pi.
Yep.
And that's a complementary angle.
Yeah, you could do it like that, or you could even just say, you know what, if I turned pi, I'd be right here, but I have to take this little piece off and back up. But either way, you have to do pi minus that turn. So you have to make sure you be a little careful, because your calculator can't give you 2 answers at once. So it's programmed to give you the negative 1, and you have to go, well, I need to go this way. And these two need to add up to pi or 180, correct? Wouldn't you agree? What are the sum of 2 angles on a line? 180. And this is 1.249 radians. So this would be pi minus. Yeah, however you want to think about it. I don't know. I don't teach pre-calc, and that's one thing where you guys go do this guy and go do this guy. We're on this for a couple days, so today's the biggest part of the notes, I think. Just getting going in the system. So you're going to move from polar to rectangular, and then let's just do 1. I took this off a pre-calc website, so I don't think we need that much practice. You can see I took it off of pre-calc because everything's in degree. There's some degrees on here. We're never in degrees. What's cosine pi thirds? 100% sure. What is it, Cam?
2.
cosine pi thirds. Oh, yeah, because cosine pi thirds is a half, correct? So that's 2. Sine pi over 2 is root 3 halves. So this would be 2 comma 2 root 3. How do we do? The other one, I know my r is just going to be the square root of x squared plus y squared, 25. It's a root 50 or a 5 root 2. I don't really care as long as you can find it. Okay? Now be careful, because when you do tan inverse 1, I want you do have to have a little critical thinking here. When you do tan inverse of -5 over -5, you have to think about what your calculator spits out and whether you want to accept that or whether you need to problem solve. So go do tan inverse of 1 on your calculator, and it's going to give you in radians what it is. Can you tell me what it says it is? 0.785. 0.785. That's this way, right? It's giving you pi over fourths, right? Because actually, what's the tangent to pi fourths? 1. Your calculator is not lying when it tells you it's pi over 4. But we know our point is 5 to, we're down here. So you have to be careful. Our angle is not pi fourths, but it does have the same tangent as pi fourths. Does that make sense? So what's our angle? 5 pi fourths, right? Or you could do -3 pi over, there's those options as well. But your calculator, again, is programmed with that arctan to be in quadrant 1 and quadrant 2. If that's where you are, you're fine. If you're not, you have to think yourself over to the other quadrants. Did I explain that well enough? Mm-hmm. Okay. All right. So now the harder part. The reason it's okay actually if you're not very good at today's stuff. It'd be nice, but this isn't really. You won't be tested on this on the AP exam or on my test. But it helps if you have an understanding of the system. You'll be way faster. So this says convert the following equations from rectangular y equals some function of x to polar, where r is equal to some function of theta. So when I'm done, I'm going to go down here and write r equals. That's what I want. And I can only have theta being my independent variable. So what I need to do, sometimes there's a couple ways to do these, but I'm just going to start. I'm going to get y out of rectangular. What did we say y was equal to? R times what? Sine of theta. Okay. What did we say x was equal to? What did we say x is equal to, guys? R cosine theta, thank you. Now, my goal is to solve for r, and it looks weird, but you do what you have always done in algebra. If these were x's and these were x's, you need all your x's on one side. It's just awkward because we're r's and r's. But I need to get my r's on one side. So I'm going to have r sine theta minus 2r cosine theta equals 1. Get the variable on one side. How does that help you solve it for r? You've been doing it for years, just not in polar. I can just factor it out. Okay, so that's why I said it's awkward. It's not difficult. And honestly, I can't remove the awkwardness unless we spend a ton of time on it, and I can't do that. So do your best, all right? So my r is going to be 1 over sine theta minus 2r cosine theta. What one do you like better? If you were in higher levels of math, which would you rather work with? The original, correct? But it's because it has no curvature. It's a line. What did I do wrong?
There's an R at the bottom.
Oh.
Okay.
Oh, yeah. Thank you. Sorry. Thank you for paying attention. All right, so if I were to graph this in polar, you'll see that line. Okay, but you wouldn't go to polar for this guy. Do you think this guy you would go to polar with? No, but if I wanted to be in polar and graph this horizontal line, I'd say r sine theta equals 4, and I'd enter r equals 4 over sine theta. Guess what my calculator would do if I graph that in polar? It will. I wouldn't choose to be in polar for these if I was working in higher levels of math because they have no curvature. But this guy, I definitely would. And there's 2 ways to get this one to polar. You really get it, so you just write it down. Or you remember that x squared plus y squared equals what? r squared. R squared equals 16. So you'd say r is equal to plus or minus 4. You don't need the negative because all the negative does is, for example, theta can be anything. So when theta is 0, I'm 4 to the right, then 4 to the right, then 4 to the right. It doesn't matter if I'd started over here, it's just going to go that way. So it's the exact same circle. Now suppose Priestley's a rule follower, right?
Oh yeah.
Yeah? For sure. And he goes, LaRude, you said we replace x with r cosine theta. And we need to square that. And I'd say, go ahead, you have it. Okay? And that is not false, so it looks good to me. And then he says, well, I'm going to replace my y with r sine of theta. R sine of theta. And I'm going to square that. Isn't that how I do it? I'd say, you do you, boo. Because what's going to happen is he's going to get r squared cosine squared theta plus r. That's what's so great about math. As long as you don't do anything wrong, it's going to work out. Nothing is wrong here. Correct? What could I do to solve that for r? Factor it out, right? And that he'd get r squared times cosine squared plus sine squared, which is what? 1 equals 16. Meanwhile, if you're more of an independent thinker, you're like, that's a circle. Right? R equals 4. So some of your work is going to look a lot different based on how you see it. And I'm going to show you this one 2 different ways. And again, I like to show you that there's different ways because usually it doesn't screw you guys up. Usually like one way better than the other. So I like to give you both. One way to do this one is to say, well, I don't have anything that's an x or a y. I don't. I darn near have r cosine theta over here, though. I just need an r. Is it legal in math to multiply the right by r? Yes? As long as you do what? Multiply left. So you could go, well, I'm going to create 2r cosine theta. I'd say, that's good. That's not wrong. And you could say, well, now I know I can replace this with x, because we're trying to go back to x's and y's. Now my r is the issue. And I'd say, get rid of it. What's r squared? I don't want r. I want x's and y's. X squared plus y squared. Okay? Now it's all rectangular, and I could solve it for y. You can almost do it in your head. Y would equal plus or minus the square root of 2x minus x squared. It's done. Okay? That's one approach. It's just to create what you want. We've always kind of done that. Or you could go like this and think of this guy. And you could say, well, here's how this is laid out. That's my theta, this is my r, this is my x, and this is my y. And he could go like this. Well, r equals 2 times cosine is adjacent over hypotenuse. Wouldn't you get r squared equals 2x? See how it's, you see what I'm doing here? It's the same thing. So we can replace cosine with x over r, multiply by r. I'm still going to get the exact same thing if I keep going. So it doesn't matter. All right, are you ready? Almost done. Theta equals pi over 3. I'm sorry, 3 pi over 4. I'm going to go draw you a picture of that. It means r can be anything, but you're always on this 3 pi over 4 radial. So if I were to plot dots, I'd say I want r to be 1. I want r to be 2. I want r to be 3.1. I want r to be 5. I want r to be -1 and -2. What's it making? A line, right? So it's kind of like the x equals 5. Why does it matter? It's a vertical line. For this one, when it's just theta, you get a line through that whole, like if that was theta equals pi halves, it's this line. Does that make sense? Now watch me solve it to get the equation for that line. Okay, so if theta equals, let's do this. If theta equals 3 pi over 4, right, then tangent of theta would equal tangent of 3 pi over 4. That is legal. Do you agree? Okay, that would mean tangent of theta would equal. What's tangent of 3 pi over 4? We should have that one memorized. What is it? Negative what? What's tangent in terms of x and y? I can't have theta, but I can have what? Tangent would be y over x. So y over x equals -1. That's the line y equals -x. Does it look like it is? It's cool. All right, last step, the last two. It's okay if you don't have much time to work. I want you to try the delta math tonight, okay? Just so you don't get too far behind. We'll do one more. This says convert to polar. Do you have this one? No? Yep.
Yeah.
All right, this is convert to polar. So here's what you're trying to do. All right, you're trying to maximize the use of your x's and y's, right? If you go over here, it's kind of a mess. Tell me how you might get started so that you could maybe get an r in there, because that's your goal.
X squared plus y squared equals
I see an x squared plus y squared hiding in there. Do you? I do. So I would FOIL, and I go y squared minus 4y plus 4 equals 4. And that's because Lainey's like, okay, x squared plus y squared. I like that because I can replace it with an r squared. These are going to go. And she's going to go x squared plus y squared minus 4x equals 0. You now have, what did I do?
4y. Not 4x.
Oh, for what? Yep. Just make that longer. What am I going to replace this with? R squared. What do you think I'm going to replace y with? R sine theta, exactly. So it's awkward, but it's not new math. It's just substituting stuff out. Now you can solve that. Remember when it says convert to polar, you want r to be some function of your theta. So what are you going to do now that you've got all your x's and y's out of there? What are you going to do next? Solve for r. How? Factor it. Yeah, just like it's a quadratic equation of r, right? So we'll factor the r out. Okay? Now if that equals 0, this can't be 0. A radius being 0 means you're stuck at the pole. You're a dot. Okay? So that it can't be 0. What would cause this to be 0 if r equaled what? 4 sine theta. This in polar will be the same graph as that in rectangular. What do you think? How are we doing now? It's weird, isn't it? It's very weird. All right, so last one. Going the other way, you're now trying to get x and y in there. So you're like, I kind of want to get some sort of an r sine theta or an r cosine theta. Unfortunately, I don't have that right now. So somebody give me an algebraic move that might help me introduce some sort of a y and an x. Do you see it, Kaden? Yeah. Multiply the bottom over. Yep, go like this. That's legal. Plus, whenever we have fractions, we don't like them, so it's always a good move. Kaden, how is that going to help you introduce x's and y's?
Factor the r in.
Factor the r in. Yep, and I'll have 3r sine theta minus 4r cosine theta. Thank you, Kaden. Keep going then.
And then
You now have manipulated it into getting what? 3y minus what? 4x equals 12. If you graph this in polar, it will make, what would it be, 0, 4, 3, 0. It'll make that line. You could test it if you want, but it will. All right, we're done. Your homework for today is, for sure, do the delta. Okay? Shouldn't take long. You're going to be plotting points and stuff like that. The other part, though, just a second, because there's two pieces. It's not due today. I have to tell you that the copy, any of your teachers told you that copies, we can't make them right now. So you have to access this. Just says number 3 and 4. So when you click on this, it's got all of the homework on here. I have a big X through the whole first part because you're going to be doing that in Delta. So if you're getting it wrong, you know. So Delta had this stuff. So it said to do 6. What one did it say again?
3 and 4.
3 and 4. For sure do the delta and try to start on that. Alright?
So we should start.
You don't. The copy room hasn't been functioning since last Wednesday. So I don't know if she has COVID or what, but we don't have a copy person and so they locked the door, so I can't get in. So luckily I got all my EV and geometry stuff copied, but you guys, I didn't. My goal was to do it on Friday. Anyhow, so for sure do the delta and I'll check that tomorrow. The paperwork won't come in yet. We have more work to do. Did it make sense? It's just weird. Polar is gonna be really awkward for a while. And then once you get good at it, we're done. Just